Would you go to day 6, planar graphs? We have 2 units, little sections left today and tomorrow. We'll finish the chapter tomorrow, and then we'll start the lab and do the review on Friday. On Monday, we'll start the next unit. I'm not going to give you a test on Monday, but we'll have our test on Tuesday. Friday, we'll have a little quiz, so just be ready for that. A little quiz, just a catch-up quiz on stuff that we're doing. A planar graph is no intersections without vertices. So when we had this beauty here, you could connect those 4 points. Where else can you connect the points? Diagonals. But the problem with the diagonal is this last one is going to cross, and therefore it's not planar anymore. So is there a way to make it planar? Yes, not simple. And now you've connected all the vertices, and it's planar. So look what happens with a cube, and you make this cube planar. Isn't that clever? It's the same connection of edges and vertices, but now it's planar. Okay? There's the polyhedron can be two-dimensionalized, if you want to call it that, into a planar graph, as you can see there. Now we like to identify groups of vertices and edges as what we call faces. And the faces are vertices and edges that contain a certain area that is exclusive to other areas. And that's the point of a planar graph, is that you can see all those faces. So we could say face 1, face 2, face 3, and like I say, there's one more elusive one. What's that? Outside. And if you look at a cube, the outside, here we have, you can see 1, 2, 3, 4, 5, 6. 6 sides to a dice, should have 6 faces. Look at which side we're talking about. E, F, G, H. E, F, G, H. That's this face here is the outside. That's the outside face. Does that make sense? So you're restructuring your edges and vertices so you can make sense out of it, and you have these faces. Now we're going to see a lot more with the faces coming up tomorrow, but that's pretty much all I wanted to mention about that. Here's a quick example. For the given planar graph G, how many vertices? Well, that's really hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 12 vertices. You just count those. The edges, you count those, you're going to get 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, and I think 15. Faces. So then we put those in. 1, 2, 3, 4, and 5. So that's easy. Then it says, find the degree of each face. Now to find the degree of a face, it says here, it's the minimum edges for a closed walk. And the key is minimum. So for face 1, what are the least number of vertices for a walk? 1, 2, 3, 4. Now we don't go back to the beginning. We just go 1, 2, 3, 4. How about face 2? Start at A. How many will there be? Not 4. See, with phase 2, you have this one, 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 this one. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait a minute here. What did I do wrong here? They said do a walk. Oh, yes. Thank you. So if we're going to do this, we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Shorter? Where should I start? Top? I think you're going to have to, no matter how you do it. Let's say I started here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you're going to be back here, so you can go there. Here? Okay. How do you do it in 10? Where would you start?
Go around at first and then along.
So are you starting at H?
You have to start, wait, you have to end and start at the same point.
Yes, but you don't count the point twice at the end. But like this one, you're going to have to go 1, 2, 3, 4, 5, 6, 7. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then they got 11 for that one. Let's do F3. There's 4. F4. There's 3, 2, 3. Yep. And then F8 is going to be 1, 2, 3, 4, 5, 6, 7, and 8. Take this one, for example. Let's say you started here. 1, 2, 3, 4, 5, 6, 7. Am I back at 1 yet? No, I have to go here. That's why that's 8. And then you don't count it there. So let's try that one more time. Yeah, this is the only hard part, if it's that, is going back to here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then you don't count that again. All right, so for homework, you're going to answer those questions, rewrite the polyhedra, and do the utilities problem we've talked about before. Decide whether these are planar. If possible, draw it. Great test questions is drawing things as planar. Look at some verification of some ideas here. And that's it for tomorrow. Quiz coming up on Friday.